Good morning and happy Tuesday, October 6th. Today we are going to be focusing on using partial quotient to divide as a strategy. I'm going to model two different ways that are partial quotient that can be used for you to divide. So our learning target stays the same as yesterday. I can develop division strategies to find the quotient of word problems. Remember, quotient is a fancy word for the answer to a division problem. Real quick, I take a look at our agenda. You have a start problem today. You're going to use what you know about from yesterday about the types of division and apply it to your start problem. There's a quick mini lesson today on partial quotient. I'm going to go through and model two different models of partial quotient. I highly suggest you get a piece of paper and write down these two strategies as I show them and model them today. So please, if you need to, pause the video right now, get a piece of paper and a pencil so you can take notes understanding these two models. Then you have two practice problems to apply what you know, and then a real quick reflection on what strategy you like to use. Let's get started with the start problem. Our start problem today actually has two problems, and they are very similar. It's just like what we did yesterday. We have problem 1 right here and problem 2 right here. Before I read both of them, I want you to think to yourself, which problem 1 or problem 2, are we having to find how many groups there will be? So once again, I'm going to repeat myself. I want you to find which problem 1 or problem 2, do you actually have to find out how many groups there are? All right, problem 1. Deanna bakes 168 cookies for her neighbors. She divided the cookies equally into 12 bags. How many cookies are in each bag? Problem 2. Deanna bakes 168 cookies for her neighbors. She puts 12 cookies in each bag. How many bags of cookies will she have? Which problem do you have to find how many groups there will be? And I want you to solve problem 2. Lesson today, the strategy that we're going to talk about is partial quotient. And remember, partial quotient means we're going to find parts of the quotient and then put them all together to actually find the quotient. Two different models are called area model, which we have heard and seen. I'm going to maybe show you a different way to do area model, so hopefully it's helpful. And then I'm going to call this written form, which you've probably heard it as partial quotient. I'm just naming it different because both of these are finding partial quotients of the quotient. All right, so I did give a word problem to give us some content to what our division problem is going to come out to be, so that you understand where the numbers are. All right, there are 384 students at Decca Middle and 24 students in each classroom. How many classrooms are there at Decca Middle? Now you can think to yourself what it's about. It's about students at Decca Middle, and there's 384, so that's my total. And in each classroom, there's 24. But we're trying to find how many classrooms are there. Now, classrooms are our groups. So this is that measurement type of division problem that we don't know how many groups. So my problem is going to look like 384 divided by 24 is going to equal the quotient. And our quotient is the answer to a division problem. Now, what we do need to know for sure is that this first number is called the dividend. Now, yesterday you had the extra credit that is due on Friday. That kind of tells you, so maybe you could use this today if you haven't done it. But the first number is our dividend. This second number is our divisor. Now, I'm going to use these terms today, so that's why I'm labeling them so you know how I can jump back and forth. I'm going to slide this up, all right, because we mostly just need our division problem to model these two forms. Okay, with an area model, you start off, I'm going to move my notes because I have my notes that help me with these two strategies. So it's two ways to model partial product. So the first thing you're going to do is you're going to create an open box. Here's my open box because with area model, it could go on depending on until we close out our division problem. I'm going to put the divisor
on the outside of my box. Now, what I'm going to be thinking to myself is, what factors can you multiply by 24? So what numbers can I multiply by 24 that can come out of or fit into 384, my dividend? All right, so I'm going to think to myself, what is something that commonly I know? I do know that 10 can go. I know what a multiplication problem I do know is 10 times 24, because anything times 10, you add your 0. So I'm going to draw my line, and I know 24 times 10 is 240. I'm going to subtract 240 away from my total. I'm going to slide this up just a little bit. Away from my total, and I'm going to get 4, 4, and 1. Now I'm left with 144. Now I'm going to think to myself, what's a number that I do know that can go, that what factor times 24 can still fit in here? I'm going to start small. I'm thinking to myself, I know 24 times 2. 24 times 2 is 48. I'm going to close it. So I'm going to take a group of 48 away. When I take that away, I have to borrow, and it becomes, I get 96. Now I ask myself, okay, can I take another 48? Yeah, I can take another 48. So I take 2 times 24 is 48. So I'm going to subtract 48 from 96. That becomes this, and it becomes 48. Now I ask myself, can I take another group of 48, or do I need to do something different? Nope. I'm going to make my box a little bit bigger, and this is why it was an open-end box. So 24 times 2 is 48. And guess what? Now I have zeroed out. I have nothing left to take for my dividend. So now what I'm going to do is I'm going to go up here. Here are my partial products, 10, 2, 2, 2. My partial products, I'm going to add all of my partial products together, 10, 11, 12, 13, 14, 15, 16. And I get 16 as my quotient, or the answer to this problem, which would be there are 16 classrooms at Decca Middle. Now for our second strategy, or another model of partial product, which is written form. And you might also know this as partial quotient. Now, this starts off by writing a division bar, but I'm going to have this really long tail right here, okay? And I'm going to put where'd my purple go? There it is. I'm going to put my divisor on the outside, and I'm going to put my dividend on the inside. So this looks very similar to what it would look like if we were doing standard form, or standard algorithm, but I have my long tail. So I'm going to show you how this is similar to the area model, where our numbers come from. I do want you to do a little trick for me, okay? And this is going to help you in the long run. I want you to make a number box. And a number box is what I mean is by thinking out your multiplication facts for 24. So if I think to myself, well, I know 24 times 1 equals 24, then I know if I do 24 times 10, which is 10 times, my factor is 10 times greater, my quotient is going to be 10 times greater. I might do 24 times 2, which I know is 48. And if I did 24 times 20, I know that's going to be 480. I might do 24 times 3, and I can think to myself, well, that's going to be 72. And if I do it times 30, 720. Now you could keep on going for a little bit if I had a lot bigger dividend, but this number box is great because now we can reference this. Okay, so I did some thinking for myself because this is helpful for the written form of partial product. Okay, so now I think to myself, 24 times what can I take out of here? Well, if I look at my number box, okay, 24 times 10 is 240. So I'm going to do times 10, and it goes on the line that you subtract your product. So see how this was what 24 times 10 is? My 10 goes on that line. All right, so now I'm going to find my new number. So my new number would be 144. Now I can't take another group of 10 out, but I can take a 2 out. I can take a 2 out. So I'm going to take a 2 out. And if you know your 3, yes, I could have taken a 3 out and you would have taken 72. But I'm going to stick with the 48. So I'm going to subtract, I'm going to subtract 48. And that's going to get me 96. Can I take another 48 out? I sure can. And this is I'm going to subtract 48. I'm going to get 48. Can I take another group, can I take another 48? Yes, I can. So I'm going to subtract. I'm going to bring down my line. I'm going to take 48 out again, and now I have come to my 0. Therefore, there's nothing left of my dividend to be able to take out. So I have zeroed it out. I'm good to go. Here are my partial products. All right, I'm going to come over here. I'm going to add my partial products. 10 plus 2 plus 2 plus 2. And I'm going to get 16, the same answer, same quotient that I had in this model as well. So as a refresher, this is an example. These are two strategies or two models of partial quotient. Okay, you take out what you can and you are just writing down what each of those are. This is one strategy that you could use to help you divide. Now that I've watched a small little mini lesson about the strategy of partial product and using the two different models, either area model or written model. I want you to try this problem. So we're going to make sense of it, and then you're going to solve it, and then I'm going to model it. So for our first read, a grocery store only sells eggs by the dozen. There are 12 eggs in 1 dozen. If there are 1,248 eggs in stock, how many dozens of eggs are there? Okay, your first question is, what is the problem about? The problem is about a grocery store. It sells eggs in dozens, and in each dozen there are 12. They have a total of eggs of 1,248 eggs in stock, but each group of the eggs come in 12. Okay, so be thinking about what we learned yesterday. Do I know the groups or do I not know the groups? So the second read, a grocery store only sells eggs by the dozen. There are 12 eggs in 1 dozen. If there are 1,248 eggs in stock, how many dozens of eggs are there? What are you trying to find? Well, I'm trying to find how many dozens of eggs are there. And since dozens is our groups, so we don't know how many groups there are. And that is also why that's helping me understand why this is dividing. I don't know how many groups. I have my total and I know how many are in each group, but I do not know how many groups we have. That is what we're trying to find. Third and final read. A grocery store only sells eggs by the dozen. There are 12 eggs in 1 dozen. If there are 1,248 eggs in stock, how many dozens of eggs are there? What information is important and what do you need to help you solve this? Well, you're going to need to know that there's 12 eggs and that there are 1,248 eggs are in stock. Okay, so I want you to try to solve this problem. Do your best. Think about the two models we used, area model or the written model. They are two different forms of partial product, and see if you can find, and it's okay that it's a 4-digit now, okay? It doesn't change what you do. All right, see how many groups or how many dozens are in 1,248 eggs. All right, for our practice problems today, we are going to turn to page 96 of our workbook, and I have given it here, and let me zoom in just a little bit. There we go. There we go. So I want you to use what you know about division. We have reviewed 2 models of partial product, which are the area model and the written model. So please feel free to use whichever one you are more comfortable with by using division, or whatever strategy is in your toolbox that you're like, yeah, this is the one I want to go. All right, so we're on page 96, problem 8. You have 2 of them to do today. The first problem is, what is the quotient? Quotient is that fancy word for the answer to a division problem. 583 divided by 11. And I do want you to show your work here because you are going to be sharing it and comparing it against mine. So take some time, do your work, and you're going to enter your answer in just a moment. Okay, your second problem that you're going to do today is problem 9. And our problem is, Carlos has 1,134 pennies. He puts an equal number of pennies into 27 different glass jars. How many pennies are in each jar? Okay, let's make sense of this problem, because this is definitely thinking back to the different types of problems we have for division. Okay, so what's this about? All right, let's read it again. Carlos has 1,134 pennies. He puts an equal number of pennies into 27 different glass jars. How many pennies are in each jar? Okay, what are we trying to find out? You're trying to find out how many pennies are in each jar. Okay, what information is important? You have 1,134 pennies, and they have been put into equal number into 27 different glass jars. So guess what, guys? You know your groups. You know you're going to have 27 groups, and you have to fair share. There's our type of division problem. We need to fair share 1,134 pennies into 27 groups. All right, so you're dividing. We know what type. I want you to show your work, whatever strategy you use here, and then enter your answer into the question box that's going to pop up. All right, good luck.